Hi there everybody, today we're going to look at an equation of a line. Now you will have seen this on another video. If you haven't, then you probably want to have a quick look about how, in terms of the equation of a line. But this one is more of an A-level technique, but it's certainly accepted, and in certain circumstances you might find it useful to be able to kind of adapt with this particular one. So I'm going to go through it. You might want to make notes on this one, but of course it's worth kind of being aware of what I'm talking about and what it's all about. So if you're not confident with the equation of a line and what the gradient is or all those kind of things, then please look at some of the other videos. And so this is very much towards kind of the top end of the GCSE syllabus in terms of its complexity, but it is just a formula, and as long as you can apply that formula, then there's no reason obviously you should be able to kind of get it in when it comes to an assessment. Okay, so let's have a look. So the equation of a line through a particular point, so I need a coordinate, that's important, and they also need the gradient. All right, those terminology are kind of key. All right, this x1 and y1 is what's going to be part of a formula, but essentially it's a coordinate that we need, and then the gradient. And again, you'll have seen this in other videos or in classes where the sort of the gradient has been labelled as m. All right, okay, so let's have a look. So I need some information. So the formula is this, okay? So the formula or equation of a line is given as y minus y1 equals m, which is the gradient, x minus x1. Now you can see from here, I've got y1 there, I've got m there, and I've got x1 there. They're the three things that I need. And everything else that's in there is part of the equation, all right? So I'm looking for three values, a coordinate, x1, y1, and the gradient. And then all I would need to do is literally plug them into where they are in this formula. All right, so say again, it's y minus y1 equals m bracket x minus x1. So that's the thing that you need to kind of remember. All right, so let's look at a quick example. So assuming, of course, you have this piece of information, and that's what you need to glean from probably the question, I need to find the equation of a line with gradient of 3. So we've got that bit passing through the point 2, 5. All right, so I've got m, that's a gradient. I've got x1 and y1, and all I need to do is literally plug that straight into this formula. All right, so m is 3, x1 is 2, and y1 is 5, which I said, and then we just put them straight in. So we've got y minus y1 equals m bracket x minus x1, and that is an equation of a line. Now you might have come across it as being in the format y equals mx plus c, and again, there's nothing wrong with that. There's nothing, no issues with that. But of course, it's a standard format for you to find the gradient and the y-intercept. And if you've come across that before, you'll know what I'm talking about. If you're not, you probably want to have a look at another video about the equation of a line, right? Because it can be in two ways. As long as it's got a y in there, as long as it's got an x in there, which I have, you can see here, I've got my y there and my x there, then that is an equation of a line, all right? So that is it done. I mean, you could expand it. Y minus 5 equals 3x minus 6, so just times the 3 by the x and the 3 by minus the 2. You could do that. And of course, you could rearrange it if you wanted. You could take the minus 5 over to the side, and it would become a plus. So minus 6 plus the 5 would give me minus 1. And like I said, you might be more used to seeing it looking like this. So y equals mx plus c, all right, and that format. And again, I'll mention it again. Please look at other videos if you're not quite sure what I'm talking about there. But any of these three here are equations of the line. They're all the same thing. They're just all in different formats and different way of writing it. But I've used this y minus y1 equals mx minus x1 because it's made my life so much easier to put the numbers straight in. All right. So if I had to answer the question, is where does it cross the y-axis? Well, if you've looked at the lesson on the y-intercept, you'll know that it crosses the y-axis at -1. All right, so that's the equation of a line using y minus y1 equals x minus x1. I just want to give you one more example. Well, maybe you're not given the gradients, and maybe you're just given two coordinates. All right, so that's what we're going to look at now. So I've got the equation of a line through a point x1, y1, and x2, y2. So these little numbers at the bottom, they just signify that that's one of them, and that's another one. All right, so they're just labelled x1, y1, because at this point in time we don't actually have a set of coordinates. So that's why you'll see it in books and paraphernalia, all those kind of different things with that kind of notation. But don't get bogged down by it, don't worry about it. It just means your first coordinate and your second coordinate. All right, that's all that kind of means. So we just to introduce you to y minus y1 equals m x minus x1. So we have a coordinate either of these two, to be honest. So we've got an x1 and a y1, so we could take that one. And again, it wouldn't really matter if you use that one either, to be honest. If I put y minus y2 equals mx minus x2, that wouldn't matter. The thing that we are missing now is the gradient. All right, so I have done another lesson on gradients, and if you remember that, then this next step will be quite straightforward, because I need to work out the gradient using these two. All right, and that is the difference in the y values divided by the difference in the x values, and you can see that notation written here. So I'll do y2 minus y1, and then I'll do divide by x2 minus x1. Now it doesn't really matter which way you do it, as long as these two are the same and these two are the same. So I'm talking about the second coordinate and the first coordinate. All right, make sure you get those the right way around. Don't be doing y2 minus y1 and then x1 minus x2. That will not work. It'll give you the wrong answer. All right, so make sure you take one coordinate, so the y2, take away the y1, and the x2, take away the x1. All right, so let's look at a quick example. So find the equation of a line passing through points 3, 1, and 5, 9. All right, well, I'm going to do y2. I'm going to choose this one first, because 9 take away 1 is going to give me a positive number. Now, it doesn't matter if you do 1 take away 9, but you'll end up with a negative number, and then you're going to do 3 take away 5, and that'll give you another negative number, and then suddenly you're dealing with negative numbers more than you would like. All right, so I normally go for the biggest y value first, so 9 take away 1. All right, so like I said, 9 take away 1 goes at the top, they're the y values, divided by 5 take away 3, and you can see that there. All right, so that's the gradient, which gives you 8 over 2 when I simplify it, and 8 divided by 2, of course, is 4. So that is my gradient. All right, now at this point, I've got my gradient, and I've got two coordinates to work with. I've got this one and this one. All right, now you can choose which one to choose. So you can choose which one to choose, that makes no sense. You can choose either of those two things, doesn't make any difference. But we're going to choose this one, that looks a bit. And why this one? All the numbers are smaller. All right, that's the only reason. So you're normally going to pick an equation trying to use smaller numbers. It's going to make your life an awful lot easier than trying to work with big numbers or negative numbers. All right, so hence using this one. But it should give you the same thing. So I've got equation of a line y minus y1 equals mx minus x1. So I'll put that coordinate in. All right, expand the bracket, which we've done before. So 4 times x is 4x, and 4 times minus 3 is minus 12. And then, of course, what's going to happen with this minus 1, it's going to come across and add, and you're going to end up with something looking like that. All right. But like I said, unless they ask you to write it in a specific form, which you might be asked to do, I mean, this y equals mx plus c form, then there's nothing wrong with you leaving it like this. All right. That is technically still correct. All right. So just read the question very, very carefully in terms of what the expectations are. Okay. Well, thanks for listening. There are other videos available on the website, so maths-school.co.uk, but I'll speak to you soon.